Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
We are really thrilled to have the Web Sciences Trust. It's now known as the Web Sciences Trust here. They just became a trust recently. Wendy has asked me to talk for a couple of minutes on what we're doing at Microsoft Research here. And since it dovetails so well with what they're doing in the Web Sciences Trust, so some of you know this quite well, but for those of you who don't, what we're trying to do is to bring together the harder sciences, so the more conventional computer science areas, theory, crypto algorithms, and mathematics and physics with the social sciences. And so as I'm sure the social scientists out there realize, people like physicists and theoretical computer scientists, and I'm one of the guilty parties, have been running around for years saying, you know, they're modeling social networks and blah, blah, blah. And the question is, are we really modeling social networks? Are we really understanding how people interact with each other? Are we understanding what the utility functions are when people do interact with each other? So we are bringing together people in economics and in social media and hopefully in more areas of social science as time goes on with the harder, more conventional, hard meaning hard as in floor, not hard as in difficult, although we've gotten a lot of jokes about that we claim that what we do is hard, but we don't claim that it's interesting. So, so we are bringing those different groups into the same lab, hoping for deep collaborations. And one of the themes that keeps coming up over and over again are networks. And probably the most interesting of all of these networks is the web, on which there are social interactions and economic interactions and infrastructure types of interactions. So we are sharing a lot of interests with the Web Sciences Trust, and we're really happy to have Nigel Shadbolt here from the University of Southampton. He is, I guess, one of the founders of the Web Sciences Trust, along with Tim and Wendy. And Jim, where is Jim from RPI? And Jim from RPI is here. And they visited us some of them visited us this summer, and we had a wonderful time. They have a summer school, which I assume you'll have again. So if you know of any, Amsterdam, so that sounds like a great place. So if you know of any students who would like to learn about web sciences, they'll have a summer school next summer. And so we're very, very happy to have Nigel speaking to us on Towards a Science of the Web.
Thank you. Thanks very much, Jennifer. Right, okay. Now, yeah, this is kind of one of the more interesting talks, because many of you in this room, I suspect, will share many of the assumptions and perhaps many of the instincts we have about our approach to studying the web. A few of you will have think you've heard this talk a good too many times before. There is new material, as I hope to demonstrate, and I'm happy to take questions as we go through. I have just an outrageously large slide deck. It seems to be how I like to support my cognition. I have to augment it with lots of slides, it turns out. So we did start this off about 3 years ago exactly. A number of us developed this thing we call the Web Science Research Initiative. It was a bilateral thing between MIT and Southampton. We had a sense that there just wasn't enough attention being paid to the people piece of the technological fabric that was the web and how they each informed one another. And over the last few years, we've been gaining a degree of support for the concept, as we were discussing here in the last few days, and in fact renamed ourselves the Web Science Trust. The point being, this is not an institutional organization now. It's there to coordinate various groups and activities and help promote web science as a discipline. I'll try to explain what that is today. We have a website at webscience.org. It describes a very high-level research agenda, curricula, a variety of resources. So, the motherhood and apple pie, although it's still surprising how often you have to make the case, is what we call the elephant in the room. Okay, it's changed the world, the web. We need to understand both the internet and the web and their effects, not least to anticipate future developments and try and understand any threats and opportunities around the corner. Is this a different slide? Is this a different talk? Oh, yes. So I didn't know how many varieties of elephant in the room there were, but I've got two, so there's one. Let me tell you a bit about my background, just because it's kind of material. I started off actually in psychology and mathematical logic years and years ago, ended up in AI, and a long time ago we were building expert systems, remember them? They still flourish, knowledge-based systems. They were tough to build. This was a system which would take a process flow sheet in chemistry and turn it into a three-dimensional layout using various forms of constraint-based reasoning. And the point being is that the flow sheet on the left here embodies huge amounts of common sense reasoning, which is not actually explicitly written down, but to get to the design on the right, you have to know that gravity makes fluid flow from one place to the other, so you don't have to put pumps in the design at crucial moments. All this kind of common sense knowledge, huge effort to get it from human engineers into computer software. And we busied ourselves, many of my colleagues did, on these kinds of issues. The thing that always struggled on, and we talked about it earlier on today in a meeting we had, was the so-called knowledge acquisition challenge. We could never actually get enough of the information out efficiently and cost effectively to really allow the phenomena to scale. Expert systems are alive and well today, but the thing that scaled was the web. And a lot of us in AI were quite slow to realize just how transformational that would be. More recently, been working with Tim and Wendy and others, thinking about what this new web that's emerging, we call it the web of linked data, is going to do to our ability to share, aggregate, and collate information together. And I've always been interested in the opportunity to put these ideas into commercial practice, and in fact I was a chief technology officer and founding director of this company, Garlic, which is out there trying to scour the web and compromise information sources for data that is sensitive and relevant to you, and uses semantic technology to do that. Somewhere along the way, just a few years ago, I got intercepted by the whole notion of, or abducted you might say, of web science. We've been promoting the notion that it's as important actually for general computer scientists to get this message as it is to convince our colleagues in social science to make common cause with us, that the web is both complex enough and unknown enough to be an object of study in its own right, demanding of methods and techniques, some of which we do not understand yet, some of which have not yet been developed or materialized, to understand it better. We famously came up with this diagram of interest. It is not meant to be definitive or exhaustive. The point is that we had this sense that we needed more than traditional computer science. We certainly needed, it had been recognized, some of the stuff on the top upper left quadrant, maths and physics, were well represented quite early in the effort to understand the web. Perhaps the stuff on the right, economics, law, political science, less well, but that is what we're all trying to promote now. It's an interesting question just how far ideas and insights from biology or ecology are going to shape our understanding of the web, but we also believe they could be important. So there's a kind of a collection of methods and techniques there which we had been observing delivered insight about the web. And as had been noted, this isn't just the grand union of everything, but it is somehow more than the intersection of all these parts. And so when we struggle to devise curricula or understand what the research questions are, we genuinely do struggle with the notion of what we have to teach, how much, how broad, how to blend the teams together to get these insights in. Now, to many of you here at Microsoft Research, certainly the results that are in will be no surprise. Everything from the topology of the web through to its various properties, whether they're power laws or small world phenomena, these came out of insights that derived and owed a lot to physicists and mathematicians getting interested in the shape and nature of the web. Real insights that have made a difference, whether it's on authority analysis or understanding how to make the web a more resilient place by understanding where the links of where the pages of high importance are. But even then, early on, it became clear that deeper insights could derive from surprising places, not least, for example, here, work by Robert May, who's a well-known population ecologist in the UK, who was pointing out that in actual natural ecology networks, weak links are very important to supporting healthy ecosystems. And there are interesting results, I think, that bear on this. And more recently, you find the whole analysis of weak ties and weak links very interestingly characterized. We know, for example, that in small world phenomena, going back right to the original Milgram experiment on how you get a letter across the United States, that the notion of efficient, decentralized, distributed search shows you a lot about how networks can collaborate, how you can exploit their natural statistics. Here, for example, interesting piece of work done by Leben Nowell on the whole, and colleagues, David's work was on looking at the distribution of live journal usage and how actually those users distributed across the United States in this case, and how in fact you could actually make predictions about local friendship structures and interactions on that based on notions of efficiently understanding the graph network. But there's always more challenges in the web than our current technology set, and one of the interesting things at the moment is to understand, well, what is it we're trying to capture in topology? Not least the fact that a huge amount of the web is being generated dynamically, it's ephemeral. Does the web graph below the graph, in some sense, that we can see as a static set of links, look the same or different? How would we even instrument the web to ask those sorts of questions? And how do we actually bring our technology together to answer these questions? Who can do this? And I'll bring this point up later on. There's actually a really interesting question about who is capable and able to answer these questions. So the essentials of web science, it's about complementary disciplines. It's about understanding how really rather simple principles give rise to really interesting emergent complexity. Many systems in nature are like this. We suspect that insights from some of the natural sciences will be important, so will the methods and techniques. We're arguing for a kind of a systems-oriented view of the web as a totality. We believe that you've got to account for the fact we've both designed it and engineered it, and in some sense, at the point it gets this complex, you need to then analytically understand it. And it's got to focus on the social as well as the technical. So no small challenge there. I'm sure we share many of these objectives in common, people in this audience. Let's give a feel of the kind of analysis that led us into believing that we really did want to constitute a discipline, the web science discipline. So here's an interesting question. It's one that's just as material now when we think about the Twitter sphere. When and why did the blogosphere take off? Well, there seems to have been a particular point at which blogging became super, entered in a kind of a really intense way into the awareness of individuals. There is now analysis of its intrinsic structure. It has many of the same power law relationships, long-tail distribution phenomena of the web in general. But the question is more than understanding that it has become phenomena. Why did that happen? What do we need to understand? And so early on in a number of us thinking about this problem, we formulated this cycle, this dependency cycle between the engineering on the one hand and the need for analysis on the other. And there are unknowns in this process, as there are with many web phenomena. So blogging, about self-expression. In fact, if you survey, as people like Technorati do, majority of blog users, 70% of them will tell you their principal reason for blogging is self-expression. That's why they're into it. That's what they say. If you self-express, how are you going to do that? Well, self-publishing. So a technology emerges, an idea of a certain sort of design. Of course, user bulletin boards have been around long before some of the blogging tools took off. But it seems to have been interesting that one of the inflection points, at the point at which really large numbers of people took into blogging, a number of really quite simple technical innovations were made to blogging protocols, not least the ability to get social kudos for your blog post by having somebody else link back to it. So methods as simple as ping and trackback seem to have been very important at the really large-scale uptake of the phenomena, not least because it incentivized people, partly socially, because they got taken notice of. Not only did they self-express, sometimes people cared. Okay, and that seems a simple postulate. Could we prove it? Can we form and establish a causal link? Well, after the fact, that's very hard, but it's suggestive. At least in this case, we say, well, you know, this phenomena then gave rise at large scale to the blogosphere. You needed tools to analyze it and look at its own structure. Some of those have come from the study of the traditional web. Another interesting thing about phenomena that go large is the perennial behavior that we see as spoofing or spamming in various ways. So when a thing gets to be noticeable, it usually gets subverted in ways that look entirely predictable after the fact, but people go, gosh, you know, are people really going to bother to do that? Are people going to write splogs? Why would you actually bother to write this? Of course, at this point, it's derived not just visibility, but usually had some kind of monetization model associated with it. There could be a real reason why you want to convince people this is an important blog, because you can attach adverts to it, and people's eyeballs might just pass over it, derive benefit. Many reasons why people will spoof and spam. Seems to be an interesting aspect of this cyclic development. And it is not one time round the cycle. This is kind of a co-evolutionary arms race very often. What you see is that people innovate, they look to adapt and improve, and around the cycle goes. Moreover, there are crucial bits of it that we won't claim to understand particularly well. How it is that people come up with the key idea of a piece of technical innovation to support a value that they care about, that's hard to understand. It's hard to characterize. Just exactly why these relatively simple engineering protocols go extraordinarily large is not always terribly well understood. So part of the mission for us in web science is to answer those questions. It's interesting with the blog that we can kind of still ask questions as web scientists about who does it, how much, why do they do it, is it the same everywhere else? Because the blogosphere has actually attracted its own set of tool makers and an industry to understand it. Technorati, of course, gives us a state of the blog report, well, reasonably often, more or less every year now. Matt Sussman will actually go out there in the latest report and ask people who's doing it. Surprisingly, this is a technology of middle years, quite affluent, high-income earners, often people who are interested in making a difference and expressing their views to the world. There's an interesting split by job title, a whole range of interesting statistics, and the quantitative surveying that can be done here is at pretty large scale. And that's the other interesting aspect of this. Yeah, and how much do they do it? Well, those who do it a lot. I mean, compared to watching TV, reading blogs for the proportion of people who actually are into the blogging is the second most substantial communication activity they're engaging. I suppose they're talking to people quite a lot of the time, but reading social media sites, Facebook and Twitter, listening to the radio, reading newspapers online, the number of hours devoted to this, interesting that as you compare the hobbyists to the part-timers to the corporate bloggers, the self-employed, you see these interesting shifting patterns. We might ask ourselves, of course, is it the same everywhere? Why do they do it? And recently, of course, things have changed. Things have changed hugely. The economy has taken a bit of a turn for the worse. Has that affected blogging? Well, in the respondents on this state-of-the-art survey, not so much. But they do blog, for those who do blog more, they blog about different things, the issues that are there. So as a piece of tracking of the social memes that are around, the blogosphere is an important domain. Is it the same everywhere? Well, we are fortunate in web science to have recruited interest from researchers and colleagues in China. There the statistics are quite different, quite extraordinary in many ways. They do blog. They also use traditional bulletin boards very, very heavily at a level that's quite extraordinary. And what are the natural statistics of the blogger in China? Not understood, not actually researched, particularly in detail at this point. So plenty of questions for the aspiring web scientist to get into, just from the level of collecting basic evidence and information. The other thing I'd like to point out, we've referred to this quite a lot, is the web's rates of change. Now, I hope you won't mind me showing you Google Trends. It's here, it's used. We'll talk about whether and how that is a good or a comprehensive tool for what we need, but it's certainly interesting. Here we're looking at notions of what is it that makes a particular phenomena on the web take off at scale, what's the environmental drivers on it, what's the characteristics of people or groups within it and using it. You can use ideas from evolutionary theory here in quite interesting ways, and just to give you a sense of this, here's the Google Trend analysis on Facebook and MySpace. Immediate inspection suggests that, well, some things, because you never quite know what the y-axis is really telling you, and in some sense that's Google's deliberate intent here. But we can overlay the two of them and notice that certainly in terms of the amount of raw search-related activity on Facebook, Facebook's having really quite a good time of late. But that's over all the regions that the Google Trends aggregating its data from. It's not like that everywhere. In fact, the other one of the well-known social networks, Bebo, pretty flat out compared to Facebook. But take Ireland. In Ireland, there is deep and consistent adherence to Bebo as the preferred social networking site. Why is that? Why do the Irish choose to blog more in this environment? Is it straightforward? What are the actual principles that can explain that? Why there are these strong regional tastes and preferences for media tools? Now, to answer those sorts of questions, you might have to get into issues that are very far from where the normal computer scientist would feel comfortable or natural. Gert Hofstede's work on cultural analysis, not to offer it over any other, but here the whole argument is, how do you understand different cultures, different cultural norms and expectations? And he comes up with a basic set of parameters that characterize cultures in terms of whether they subscribe to different forms of power-distance relationship. So how power is distributed in a society, or how far individuals go to avoid uncertainty in the workplace or in information seeking. Is this an individualist and collectivist view of the world? You can argue these are very coarse-grained, but the interesting thing about this sort of approach is the extent to which it's been used to try and characterize and capture something of the differences between preferences. So here we have an analysis of, on a simple grid representation of the UK and France, Spain and Arab countries in terms of preferences. This is actually original data from his analysis and study of IBM employees. How does that work in the context of social media deployment? What's the connection between these sorts of paradigms? These are the things that in web science we're struggling to understand and resolve. Is that a piece of methodology that should be appearing in the curriculum for our students? Is it enough? Does it have enough face validity to drive, to deserve serious attention? This is something that one of our colleagues in the Web Science Trust, one of our directors, Nosh Contractor, very interestingly has presented in the last few days, work that's well known. But the work on, again, one of the fundamental drivers in the web is social connectivity. Why do people choose to be associated or friends with, or in other ways linked to other individuals? And here the interesting thing is that the network analysis becomes enriched by a notion of why you bother. Is this person like you? Is this somebody who's important and you feel you should follow? Is this something that's going to meet your immediate self-interest, and so on? And here again, the analysis and the work that he's been doing has really realized this whole notion of motifs, that there are different patternings of the social relationships depending on the underlying causality of the reason the relationship is established in the first place. And the question, of course, is, do these motifs actually occur differently in different kinds of web-based behavior, whether you're exploring an information space, trying to mobilize a set of individuals together in a common cause, looking to form strong affiliations with individuals or organizations. His analysis, very much ongoing work, is looking at this in the context not just of the web, a variety of network contexts, but at really very large scale. And today he was talking about the analysis they do on multi-user, very large-scale multi-user games that support this sorts of insight. We would argue that these sorts of analysis, these sorts of insights, are hugely important for the web scientist to have a sense of. Because at heart, we are trying to understand phenomena at the scale of, well, we take collective intelligence as an example. How is it that people are organized or motivated or incentivized to give effort into communal, very often freely given exercises? Wikipedia is the well-known example here. And again, the natural web science approach to this might be to describe it, to analyze it, to look at its shape, its link structure. This work's done, it's in. It has a remarkably similar structure to the web in general in terms of a strongly connected core, the extent to which links within the core articles show clear scale-free properties, and so on. What is a little less understood is the stuff at the bottom, the issue around why do communities form in these areas? What are the values and obligations that actually accrue? What are the incentives that seem to apply? And, as it seems to be the case, how many in the actual population of people who might read Wikipedia or even be have an account to author an article are actually busy, actively contributing? The interesting insight seems to be that it's a very small number of individuals who actually do an awful lot of the authoring, but a lot of the eyeballs are there for repair and correction. So understanding those differences seems to be important because, and again, putting up other corporations here, Yahoo certainly has a deep interest in this whole issue, as many corporations do, of understanding these questions, because they want, and we want, to understand how you support collaborative innovation, how you support, in a sense, deriving value from effort given at often very marginal costs, if any at all. But if you do that, how do you trade off the risks? Authorless content, who are you going to sue if you should take some of that advice rather too seriously? So the issue at large scale is what often you should trust to believe or follow. Just to relate, a student of mine, a recently graduated PhD student, doing some work on expertise detection. So one of the things we're after in web science, remember I mentioned the whole notion of spanning and spamming as being a phenomenon you see typically at large scale, was looking at tagging. Large-scale tagging behavior in Delicious. Delicious is enough scale that there's people out there who are interested and willing to subvert the actual tag behavior. So if you take the bookmark history of a web page, what's that look like? Well, here's actually a map reduction program, book written to explain the process. A bunch of individuals who actually decide that this is a damn good book, should be followed, important. And as actually you look at then against the history of actually what happens in these systems, inevitably, descriptively after the fact, you start to notice there are obviously discoverers and followers. And one of the interesting things is that the discoverers in these domains often constitute the experts. But how would you moderate a recommender system or an analysis and ranking system in the face of that kind of insight? So you can take something like the HITS algorithm, you can enhance it with the notion of types of expertise. Can we give a profile to different types of expertise? And this work's done some really rather interesting both modeling. So first of all, coming to a view that you could usefully talk about different ways of being a user of tags in Delicious. So you could be what the geek actually is, the super expert, the person who really gets in there early on. Veterans have been doing this kind of tagging for an awful long time. Newcomers, new to the game, not entirely confident about the domain either. Can you tell them apart? Do these different algorithms that discount tagging behavior over time and in terms of authority models actually buy you anything? They buy you a lot, it turns out, in detecting those who would seek to subvert or undermine the tagging behavior. So again, you'll notice these terms are charmingly the flooders, the promoters, the Trojans. These are people who in various ways have special interests in undermining or changing the general tagging behavior. Let me give you another example now that's exciting us a lot in web science about a phenomenon at scale. It's linked data, otherwise, well, I would say formerly known as the semantic web, a variant of a simple set of principles at one level that we can take. I'm sorry.
Is it different from the semantic web?
Oh, please. How is it different? Good question. Yes. How is it different? Well, it's a different name. No, it's simpler. It's not requiring that you rush off and spend huge amounts of time doing description logic reasoning over complex ontologies. Typically, linked data web is about relatively lightweight ontologies where the trick is to make very, very clear many simple statements in the language of choice, RDF on the web, that describe data sets or data in web pages on the web. So that's certainly something that is a topic well worth another seminar. I'm absolutely convinced that Tim would be delighted to give it as well. But we are clear that in some sense one of the problems was that the semantic web, when it was originally being promoted and launched and thought about being an exciting area, got rather into the complexities of inference and representation, where the power was going to be in representing rather simply lots and lots of atomic facts and linking them together, moving from a web of documents to a web of simple linked data. So that this diagram here, which is the linked open data sets. So these are data sets that are available openly, non-proprietorily. One of them at the core is the so-called DPpedia data set. This is all of the articles in Wikipedia. They have a little many of them have info boxes in the top right-hand side, which are the basic facts about the article, you know, the who, what, when, where. Those extracted essentially and re-represented as an RDF graph, all of them, for all of the articles. It becomes a very, very importantly linked to resource, because that resource, when it's linked to GeoNames, which is a geographic gazetteer of places and latitudes and longitudes, or linked to open data sets about music, or the CDs written, or all the artists who have issued CDs, these data sets become aligned and joined at key points of shared classes, and you start to get this interesting phenomena of unanticipated reuse, that people can make information mashups with these simple standards linked at very large scale. In fact, you can see the scale difference, 4.5 triples 4.5 billion triples in March 2009, much less a little earlier, a couple of years earlier. And the feeling is that what that's representing is that the ability to generate surprising and unexpected data integrations and results from this starts to really take off. And in fact, if we can, people have begun to look at that, again, power law analysis of the link structure in this part of the web, this new kind of the web, to understand and derive insights about how to build it, exploit it. So these very simple principles, 4 micro principles that Tim enumerated here, essentially giving those simple atomic RDF propositions a dereferenceable web address, providing a data access language for the web to go on top of all the repositories where you'd store this information, gives you an ability to build really very surprising applications. Well, we hope there is anyway, because both Tim and I have been commissioned by the guy in the middle, who is our Prime Minister, to do something with that on the public data in the UK. Now, in the US, there is a data.gov initiative, which, in fact, Jim has been involved with trying to convert much of the data there into linked data and produce a range of interesting applications off the back of that. What we are endeavouring to do is get the commission from the government to, in some sense, push the departments to think of publishing their data in that form at the outset. Now, that's a potentially game-changing position. If we can actually get data.gov.uk set up with a set of proposals to release data in this way, to licensing it in an open way, this can be the conditions that can change the game. We've currently got a developer site where we've got over 1,100 data sets, 1,000 registered developers, and we're beginning to build. At the moment, you have to register to get into the site, but at the end of the year, this is going to be released generally. You can begin to get in, interrogate that data, and do the stuff that, in some sense, we've wanted and been minded to do for a long time anyway. This shows you rather nicely the tax spend for the British taxpayer per day across all of the services. This is a visualization of traffic data. We take traffic counts in the UK. This shows you the difference from 2001 to 2008 in the central London area here. That's the congestion charging zone. Red is a decrease, blue is an increase. And we find that whatever else has been happening, with this data made available and re-represented in these tools, we can notice real policy changes. A decrease in one class of vehicle, in this case, happily an increase in bicycle usage. And not only that, evidence-based policy can be driven off the back of these sorts of data integrations. So we believe that the excitement in this, here is the main UK road system, and the blue shading there is indicating increase in heavy goods vehicle use, and the red a decrease. Knowing that, being able to analyze it and access it easily and represent it, hugely important. No less important is the issue of locality, hyperlocality in fact. Not everybody has got broadband access in the UK, alas. I doubt they do here in the US either. And one of the things is that you can actually take these tools and methods and supplement them with very traditional print method. This is your neighbourhood postcode. This is a very fine, postcodes in the UK are down to about 4 or 5 particular houses. Okay, so that's the grain size. And
I'm not sure whether you know, but the U.S. government in the stimulus package has allocated $7 billion for hooking everyone up to broadband. So.
Yes. Well done. Well done in the U.S. We haven't got quite such an ambitious stimulus, so I'm sure they'll all be the end of very high quality services. But that isn't the case in the UK. One thing you will be able to do, of course, in the US is track the spend and success of those projects, because with data recovery, no, you don't think so. The allegation is, certainly from the administration. Pardon?
Right. That's not part of the funding. The studies were not funded.
Ah, how interesting. Well, it's interesting how it looks from the other side of the pond on this. But certainly the interesting thing is the extent to which information that is collected by human agencies, by sensors, by devices, by the web itself sometimes, reintegrated and represented in this new technology, this new set of standards, will be able to really change the way in which the country basically runs. Except that there's a whole bunch of issues that have nothing to do with the technology and have everything to do with the culture and the organization. For a web science perspective, it's issues around people feeling proprietorial about data. It's issues around license impediments. It's issues around people feeling that if you give the data out there, people will interpret it in a way you didn't anticipate or intend. That's a very strange response to a scientist thinks, well, of course they will. That's what happens. The data is open for debate. It's contestable. This is not always the model in general out there. It's not always the model in science, is it, in truth? But the whole notion of how we support people to feel comfortable about the way information is released, that they collect, what it means to make it available, hugely organizational, hugely to do with policy too. So how are we going to get the methods and ideas that we talked about earlier, the technological base, embedded in policy? You can't escape, ultimately, the economics or the law. Okay, I've talked about this, I talked about the economics. One of the real challenges, I think, in this whole area of data liberation is how to persuade people to make it available, because the economic analyses are often, often people will make money out of selling an information resource, and can you provably demonstrate that giving it away derives more value? In the UK, we have the position where our mapping agency charges for map data. It was tasked to do that. It was one of its requirements a number of years ago by government to actually support its mapping activity. A report, the Cambridge report by Rufus Pollock and other Cambridge economists, tried to look at deriving economic analyses of the value that could be generated to the economy at large if information that was deriving on the order of hundreds of millions of pounds were made freely available. And the question then, of course, is how far, as web scientists, how far does a regime of open data publication enhance or innovate the private and the public domain? How much value is derived from that? And interestingly, some evidence that simply throwing all the information out there isn't necessarily the optimal solution, but it's important to know when release is going to build a larger economic value. And so the demand there is really for good economics, to embrace and work with economists to think about models where the cost of free, as it's sometimes called, where there is a significant cost in gathering the data in the first place, how do these two things tensioned off against one another? The other thing that our web of open data or linked data is going to throw into the foreground, well, it's always been an issue, of course, is the whole issue of privacy, trust and security. Increasingly, information as it's aggregated starts to exquisitely triangulate people. You can infer a whole load of not just lifestyle statistics, but even to the level of who and what they may be. What kind of profession, perhaps down to the level of actually de-anonymizing them. So how, as web scientists, are we to understand and deal with these issues of trust, accountability, and the use of information is important. Okay. Let me wrap up the talk with a number of cautionary observations. Of course, we're hugely enthusiastic about the Web Science Project and about the kinds of mission that you here have at the MSR Lab. One of the challenges has always been the avoidance of two cultures or money cultures. C.P. Snow in the UK, famously in academic writing, in the 50s, in fact, 40s and 50s, observed that one of the curses of the British establishment was this huge division between science and humanities. And it's been confirmed and reinforced in many subtle ways over the years. They're usually false dichotomies, we're not immune from it in even the effort to try and reconcile engineering and science, I would suggest. I have heard people kind of denigrate mere engineering as against the lofty understanding of analytic science. They're usually false. When Page and Brin came up with an analysis and understanding of importance and relevance mathematically, then had the understanding to build efficient computational methods to support it, and could actually build the engineered networks to reasonably put that idea into the world. They were combining, I would say, in the best tradition, engineering excellence and scientific insight. And we have to have both, it seems. We have to have both when we engage as social scientists with analytic scientists. So many cultures, two cultures, important to kind of resist that, stay on our guard. The other rather important issue that I think we have to struggle with is many of these experiments require collection of data in the large, in the very large. And the conditions for sharing and using information is maybe going to have to require a new form of research alliance, different kinds of research compacts. So Google Trends famously put out a paper in Nature last year where they were building had derived a model fit against search terms in influenza outbreaks against actual reported flu outbreaks that have been reported to the Center for Disease Control. That traditional process took a couple of weeks to get the data back to the data centers, and in fact their model was able to track the actual real observed outbreaks very, very closely in, literally minutes of the search terms being entered, of course. So who can do these experiments? Google has that collection of search term data. If I look at the world according to Google, I'll see one set of phenomena. If I look at it according to another search engine, Bing, for example, I'll see the world somewhat differently. And if I look at it in terms of a search engine that still covers 6 billion pages of the web, they happen to be in Mandarin, Baidu, I'll see a different version of reality. So how are we going to cope with data collection at scale that's representative, that's understood, that's transparent? What sorts of common infrastructure and macroscopic tools are we going to need? Finally, things change. Of course, we understand this, but it is salutary to remember that our environments change. 9/11 changed our context forever. It meant that huge amounts of research funds were moved towards certain sorts of analytic work. The credit crunch is changing our context again. We change our own context as researchers. And it's interesting that people might ask, well, where's, in ARPA, in DARPA, one of the major promoters and enablers of research was, for better or worse, military expenditure. Where has military expenditure been in the development of the web? Kind of interesting in a way to ask that question. In the UK, we support a number of military initiatives. They do throw into very high relief challenges that are fundamentally of a web science nature. One of the big ones is information interoperability. If you want to see an example at large scale of the difficulty of common class and information sharing, look at the current operations in Afghanistan. The number of agencies, the number of countries, the number of information systems that are there and deployed, and the difficulty of arranging for information to be easily connected together in an environment where finally coalition partners are at least running IP protocols and are increasingly using web tools to support their behavior. So that in the actual world of military research, we find that there are actually quite interesting beginnings of research that could bear on the larger commercial world. There's an assumption that the commercial world has a strong set of imperatives, and in fact those are the tools that will find their way back into a military context. One of the important ones, of course, is security. Policy-based security research in the web of military coalition partners is an area where some quite interesting research is going on. But I think it's not the case that, as in the past, the military has been the principal driving function. Here, very often, they draw down and see their best efforts overleaped by developments in commercial technology and software. Okay. Interestingly, I would say that here the analysis of the systems that are being deployed there do at least recognize that the fabrics at every level are networks, whether the underlying communication stacks, information sharing, and the social and cognitive piece that we've been talking about here today, whether it's shared understanding, distributed planning, these are realizations that are gradually making the way through to the way people think about sharing information in these contexts too. And the obvious one to perhaps finish up on, the thing that will change us is, of course, the rates of change of our technology in sheer terms of power. Whether it's information densities or cycle processing, we are going to live in a world in which the ability to catalog information is just extraordinary. So SenseCam is a nice example of the beginning awareness of a technology which will go further to allow us ultimately to record entire lives in terms of our information processing. What will entire lives, well, look like in terms of information and processing challenges? Those lives will be re-represented on the web, make no mistake about it. The services that will be offered will include automatic annotation of your photos, timeline narrative generation, indexing, retrieval. The sheer amounts of this, the extent to which it becomes highly personal to you, requiring to be shared between particular close networks of individuals, this again will change our context very dramatically. And finally, of course, the world of mobile technology, where we'll find the web represented in places and spaces that are going to be profoundly disrupted by its arrival, or indeed profoundly disrupt and subvert the technology. The web and the web science that's going to occur in these contexts is going to be every bit as important and may in many ways surprise and humble us. Okay. Web science, we're about an ambitious agenda of research and analysis. We are seriously attempting to engage with and embrace colleagues across the world who share assumptions and values, interest in research. As a trust, final plug, we have a number of things going on. We are indeed influencing our funding agencies to some extent. Lines of work are being written in both national and European agendas. We've had a number of workshops as a trust where we take a particular key topic area and understand how web is transforming and developing it, whether it's scholarship on the web, very interesting, the use of open access models, the use of a whole range of citation tools that use network analysis. In fact, we get assessed, our salaries and promotion prospects assessed by virtue of tools that allege an impact or allege a particular currency of our work. And how confident are we about those methods and insights? So you can read them here. We've engaged in conference, workshops. We're about to launch an important meeting in 2010 in London. The Royal Society has its 350th anniversary, and web science as a new research frontier is going to be featured there, and a number of people will be trying to capture the very best of research and understanding in this new world. So that's it. It's about 50 minutes, I think, of me talking at you, and so happy to take questions. Thank you. Okay. There was a final. Yes.
areas and stuff. How do you attract a student? How do you tell them that, look, if you learn all about economics, sociology, mathematics, physics...
You're not going to teach them everything. No, you're not going to teach them everything, of course. That was illustrative of methods that might be appropriate. I would imagine that, well, the curriculum that we see being evolved and designed are for different purposes. The question is, what is the irreducible piece? If you think of your medical degree, anatomy is pretty important, some biochemistry is pretty important. You end up being a specialist in endocrinology. The notion of what you want them to understand, we would suspect that some understanding of networks and the properties of networks is going to be indispensable. We would suspect that some understanding of how economists account for value and assess value is going to be important. But we're not seeking to provide huge depth in everything, and you simply can't. You might decide when you execute a web science project or an agenda that the best thing that you're going to look to blend teams. In fact, in research, that's often you want people with deep understanding and a common sense of what brings them together. And so the kind of competence model is the T bar at the top is broad, and there's some real depth in a particular number of areas. But what areas you choose to be specialist in will really reflect your own skills and competences. At the MSc or PhD or the undergraduate training level, the bits that we're looking to pick off and say, to understand how the web really works, you're probably going to have to understand something about the web technology, the economics of the web, what it means to enact, or how easy is it to enact any legal framework on the web. The point being is that you can be the best engineer on the planet, but if you're entirely unaware or appreciative of the fact there would be an issue about privacy or jurisdiction, it kind of comes as a surprise to people. And we want to kind of really help people to see the interdependence of those methods rather than give them everything as an offering. Yeah.
With all the hands, I'm surprised you could see through the forest of volunteers. I'm very intrigued by linked data, but just thinking through, I'm curious as to your thoughts as to some of the detail. And thinking through in my mind, the farther we go from measuring physical phenomenon to social phenomenon, the more the definitions become important. For example, definitions of race vary across time, they vary across the country.
Sorry, what I missed?
The more you move from measuring physical phenomenon to social phenomenon, the more and definitions for things like unemployment are remarkably supple.
Yes, good point. Yes.
And also in terms of geography, the census is a bubble, but the majority of their geographies change between each census. So
that's really interesting. And the great challenge, yeah. Mm-hmm.
The definition itself is potentially a problem. And kind of, what are we going to have to think about once we begin to work with linked data?
You're not going to harmonize everything. I mean, indeed, there are essentially dialects that describe your way of characterizing or partitioning the world. But one of the interesting things is where you do get agencies or organizations who wish and need to share, where you do have to understand where the commonalities are and where the variance is. So crime statistics would be a very good example. Actually how people choose to measure something as simple as violent crime. Well, simple. Violent crime. Statistics are put forward by the UK Home Office that allege so many violent crimes have occurred. There's been a decrease. Definitionally, there are issues there. How it's reported embody more issues. Is it the same thing as comparing us with France? And yet there will be a real desire to begin to share environmental factors, geographic factors. So there is always change, but there will be a strong desire to, if you're going to, and of course this happens at the local level as well. Within the UK, there will be regional variation on how this data is collected and managed. That won't stop the imperative to begin to share across these various resources. And then the challenge will be agile ways of aligning your information models, understanding where the join points are, understanding how to reflect genuine differences, and how you overlay these graphs essentially of linked data will become very critical. Yeah. And actually accounting for the provenance, so having some kind of design history of why the distinctions are made in the way they are. Yeah.
It seems actually that what you need is a platform that can put together these different languages and the different representations. I mean, within something much simpler like hospital data, there's a product group at Microsoft that thinks about this, and there are all these, every different machine measures things differently, and so in order to just use that information, you need some kind of a platform that translates it. And I wonder if in the context of linked data, if there could be anything like a platform that would do, with appropriate human intervention, some kind of normalization.
Well, and I think that there are people working on this kind of notion that you could have some degree of automatic alignment. Perhaps you could do things that are driven by instance-based aggregation or statistical alignment. Others who will say the right thing to do is to sit down with support tools that allow you to model differently. One of the things, though, about the linked data web is that it allows you to have, actually supports multiple schemas, so in fact, multiple vocabularies. And that is quite powerful. What it doesn't insist is that you have to have agreement across everything, and that some areas you will identify as being essential. So geospatial coordination is quite an interesting one. Although the administrative geography will change from census to census, and it can be quite a tricky thing to work out the concept of a city in Italy as opposed to a city in the UK. They have actual different legal meanings and definitions. That you could imagine tools that are, and platforms that are aligned to support that activity. Part of them will be social information wikis that allow, in some sense, a degree of consensus to form around a certain sort of mapping. Will support different communities doing it in different ways. So there won't be any single answer. But the ease with which certain sorts of information friction are going to be removed by these new standards will actually throw all these issues up, that's for sure. Yep.
Well, I was about to ask a question about platforms. I mean, you talked about sort of memories for life, whole life representation on the web. But I mean, another kind of platform, and I'm sure many people here are familiar with, is this notion of the virtual patient, the medical sense of digital me, where the individual's medical data on the web becomes the content of the platform. That can, of course, sound completely sort of individualist, like the memories for life individual does. But the important area there, I think the important insight that the web offers, as it were, the matching against evidence, is that the patient doesn't just want to know about their own facts and hear them put into their medical data put into relationship, but into what other classes do I fall?
Right.
What happens to other people like me in these classes? And that, I think, is slightly different from the memories for life of the individual. It relates the platform of the individual to a wide space of internet data. And that, of course, is one of the things patients want to know about, isn't it?
Yeah.
And they want to be the patient with.
Yeah, indeed. And I think the medical example is a good one, but there's even a deeper issue, I think, of the notion of personhood in your digital representations of yourself. What versions of yourself are you interested in? Is it from a health perspective? Is it from an educational record perspective? Is it? They'll be different. Yeah.
Where do I fall? Who am I like? It's almost sort of it's almost like a recommender system, but not to recommend, but rather to know outcomes and prognosis.
Yeah, and actually there's some very interesting work on. We heard at the International Semantic Web Conference work on patient trial systems where they're trying to gather together volunteers and get them matched against studies and outcomes in just this kind of way.
Patients like me does that fantastically in 5 or 6 different diseases. I mean, and that's exactly what they're doing. They're trying to match you up so that you'll know what your prognosis is.
Yes, that's right. In fact, there was it
was mentioned in one of the talks.
Yes, that's right.
It's really incredible.
Yeah.
As one of the motivations for bloggers, and that's kind of on the web of documents. But how do you see what self-expression in the
web of data? That's a very interesting point. And releasing the web of data looks different as well, because blocks of data become available as they're published in these formats, sometimes very large blocks of data. What are the motivations behind people doing this? Why should they choose to do it? There's a very interesting and active developer community in this space who do it because it's there to be done, because they can, because they care about a particular set of issue, or they feel really importantly that this data should be available to purpose as simply as possible. So I think third sector, we call voluntary sector, particularly represents a very interesting space where this data gets repurposed. So we have in the UK a charity, mysociety.org. There's a Sunlight Foundation, I think, in the US as well, where this data is often being used to hold public services to account. Famously, Fix My Street. You know, this is a place where you can report the potholes in your street. Seems routine, mundane. Why would people care? As this starts to happen at scale, authorities become exquisitely sensitive to the fact that they're in a league table, they're not very high up it, there's lots of people kind of blogging and posting and twittering about this. And somebody has gone to the trouble of thinking, well, I can publish this data, I can think of a way of actually collecting and re-representing it. People feel very strongly about geographic data, for example, that to the point that they'll go, if they can't get the data from an authority, they'll go and map it themselves. So I think the whole spectrum of reasons why people collaborate and participate will be reflected in the data web in the same way they are in the document web. Some people will be followers, some people will do it for the sake of doing it, others people will do it because they believe they can make money out of it. Yeah.
You know, one thing that you said, I mean, there's the self-expression and putting up the data, but there's also the self-expression and how the data is visualized and how it's represented.
Yes.
And like Many Eyes, which was done by
yes.
Vegas and Wattenberg, right, is doing exactly that. It's that there's a lot of self-expression in the way you take the same data set
and represent it
and represent it in ways that that will have effects on different groups.
Yes, indeed. Yes, indeed. Tim.
Could I add to that? For a lot of businesses, there's some data which is just in a business interest to publish, like the product spec. Just as they know, why do people publish catalogs and push them through your door? You know, every catalog page is a link back to the possible sale. Same thing after a while when people start to buy things by putting in all the data about the things, the things for sale, and then running an algorithm to find out which sort of tires to get the car or the truck.
Yeah.
Then you have to have a data feed to exist, and it'll just make it'll be fundamental part of doing the business.
I don't know whether, I mean, and of course in expressing this data you will have unintended consequences, and the fact is we don't always see ahead. It would be nice if web science or those researchers in this area could begin to pull out the anticipatory effects of this. I hope it wouldn't be an impediment. Recently, marinetraffic.com, this is a complete map of all of the world's actual marine traffic. Here are the IAS feeds on. Okay, that's the Galway Fisher proceeding at 8 knots on a bearing of 267 degrees, and this is in fact the Isle of Inishmore proceeding at. This is everything. Now this is extraordinary, but yeah, it's been a boon for the guys off the Horn of Africa. So it's it is truly fascinating what you discover as you live in this world of increasingly integrated digital assets. And there is real alarm, I think, in some quarters about the exquisite precision and fidelity of this kind of capability. This is updated every 90 seconds, so it's not exactly real time, but hey, you know, ships don't travel that fast anyway. Yeah.
Within a certain distance of one of their receivers, that's why they don't have any ships in the center of the ocean.
Yeah, IAS has some limits, but actually in some areas it's exquisitely precise. Yeah, the English Channel, they can't. Well, they legally can't, of course, in some traffic lanes. So English Channel's pretty decent, but yeah.
Are you military
Well, no. They have a few channel exceptions. Some of it is, yes, yeah. Small yachts are too.
There was a lot of interesting discussion here on sort of the data that's created as if it was sort of like and this is ships are doing stuff. Now there's a supplementary data that's being created of us consuming the ships doing stuff.
Yeah.
The sort of the consuming web or the interpreting web or the watching web rather than the data web, does that require different models, or is that simply just going to feed back into be more data? And there's a second part to this question is, what happens when things go peer-to-peer? So it's not like there's a central server where we can look to get like the Hitwise traffic. And how will that sort of gum up our capacity not just to see what's produced, but know who's consuming it?
Yeah. No, I think it's a very good question. I mean, that if there was a serious or a substantial reconfiguration of the underlying architecture, what would that do to our methods of estimation of relevance and importance? And that I think in and of itself would be a great piece of anticipatory web science. You know, if everybody just adopted gossip protocols tomorrow, what would that actually do to our ability to instrument many of the phenomena that are driving a lot of the value proposition? Yeah.
The consuming, is that the same? Is it just we're just going to fold it right back into it's just more data, it's the same thing? Or is, the lurker problem? Like, how do we deal with lurkers? How do we know about those 80%? We know that.
Well, yeah, I mean, there'll be a food chain of this stuff, won't they? And people will consume and then feed back. And will it change their behaviour by virtue of being consumers then producers of this stuff? I don't think we've really in the data web, yeah. I mean, you're starting to see it. Well, let me tell you, a good example, I have to say it because it's where we live, is research publications. If you want to see a wonderful example of how the ability to measure impact and citation is driving behavior to reinforce a particular model of and preference, it's really distorting the landscape. And people know they know how to game these systems now. And we're very good optimizers in this space. So when you decide to measure X and then award it some significant payoff, you better be sure that you understand the consequence.
Doug Arnold has just written something. He's the head of SIAM. I'm not sure if it's been published or not, but it's going to be published in SIAM News or in some other SIAM publication, in which he talks about what the effects are of these impact factors. And there are all these junk journals that don't referee at all, that have grown, that inflate the impact factors, and then
they're 5 times as high impact factors.
Right, and then some of them have no one has ever heard of, no reputable scientist has ever heard of, have some of the highest impact factors, and when so it's this whole industry, and then you actually often see it in students who are applying from China and from India. They will have publications there, and as Henry and I were talking about, it's not clear whether they even realize what they're doing publishing there instead of publishing in a reputable journal.
Yes, you.
There's another interesting aspect in the open access area. So there's this well-known ArchiveX repository where mainly people from nature sciences and physics publish their data. And they have the policy that you can upload your paper at 4 o'clock in the morning. So at 4 o'clock in the morning, there's a whole bunch of people sitting uploading their paper, and it has been proven in a paper that the papers who are on top of the list, so that are the ones that are first ones in the morning, they are cited higher, regardless of the content. Right? So, I mean, all these aspects have to be taken into account in the web and in all those new methods and ways of publishing.
So, think about how all these. So that's a system which then starts to just do strange things among itself, just the citation system. But now, if you imagine you take systems like this, like people looking at the shipping, looking at the weather, and start using those individually in their own computers to affect in real time how they invest.
Yeah.
So on people's home computers, they're moving their stocks gently as a factor of all kinds of things which they think may be hooked up. So that you end up with something which
we've experienced.
We can see this with crime statistics being published. This is the kind of a very standard kind of mashups now. It's being driven off of quite a lot of public data, which is why I put it up. But this is the London area. This, you specify what tube station is closest to the one you go to work at. So I don't know, Covent Garden or whatever. I suppose that was exactly the one that was in there. And then it will give how far you want to live from the station and what you can afford. These are the moving house price averages for this particular area. Those are those. That will begin. Information's going to inform people's decisions. It's going to drive. People will find those little kind of areas that are exquisitely priced, and together they're going to change the market in just the way you described. Yeah. It's when it changes the market in ways where you really do worry whether the underlying use of information, its provenance, is well understood, and I think that's where we're going to have a hugely important role.
Well, just thinking back to the Somali pirates, I mean, will there be situations where, as you say, are using these real-time shipping programs? Will there be cases where it will be justifiable on sort of moral or legal grounds to plant false information? I mean, one answer for Somali pirates is to have 10,000 fake ships of desirable description, so they couldn't possibly tell where the real ones were in that area. I mean, could that be justified? I wonder. But I can imagine someone would want to do it. You couldn't find a real ship to attack.
Discuss. Yeah, I mean, so we know we.
Well, yeah.
We know people implant information that is false to do things like follow inappropriate IPR usage, for example. So that this is done already to track.
People do it with stocks, right?
So one of the things we think, and Nigel mentioned before, is that the whole provenance thing is very important in this. So until we can really track data and data use and who put it in and things like that. So we're doing one of these with a crime map, and we sort of separate by color what the police have authenticated versus what people are reporting in. But you still can see an overall map and turn those on. Because again, you need, but that's a very simple one. When that goes to somewhere else, I think that's a
right. I mean,
big problem for this
most of the interest of the web would be things which, well, at least sort of, if you think about the new media, Twitter and stuff, it's sort of things you learn from somebody else, who learned it from somebody else. So I think the notion who really put the data in makes that much sense, does it?
Well, but he's talking about it being validated, right?
Because it sort of comes from many.
But if you look at some of the new search sites, for example, so one of the ones I like a lot will give you a sentence that includes your search term and then say source, exactly where it came from, not the URI, but actually what that
So
which
search engine?
SenseBot does this one, but there's another dozen. Bing is starting to do some of that, and some others. So.
Yeah, and Sigma from Derry, which is a semantic web-based engine, gives you the origination of the data, the RDF that's being extracted, and you would expect that you develop clear preferences for for the quality of information characteristics of particular sources, or not. Yeah.
And source is a great thing to include, but it's just the starting point. I think actually, so we've been exploring ways of figuring out what the level of trust or reliability is in some automated way. When you look at things like Wikipedia, so we've been looking at revision-based metrics as well as reverse link metrics, as well as potential other metrics. Because the source requires that you, the viewer, know the reliability of that source. But you might want to use things that automatically do some ranking.
Yep. Okay, all right. Thank you.